Hi everyone, welcome to my shed. This is how in geology we do our blended or distance learning. For this lesson we're going to be working on pages 14 and 15 of part 1 of Theme 0. So we're looking to finish off the Theme 0 booklet and I'll be collecting that in to have a look at what you've done after we finish this period away from school. Anyway, what I want to do today is to think a little bit about how we know some of the geological ideas that we've been talking about. I think there's a danger in thinking that these ideas that we talk about have always existed. We've always known how the Earth works. And that's really not the case. What we talk about in class is the result of hundreds of years of geologists making observations and working out how the Earth works. And what I want to do today is look at one of those geologists in particular, someone who had a massive influence on what we know and how we think about the Earth today. This is the guy, William Smith. He lived over 200 years ago. He was an engineer, a canal builder, a mining engineer, and perhaps most importantly, a geologist. He didn't find life easy though. There's a link in the emails to a series of videos that was produced by Scarborough Museum all about his life. It shows some of the real struggles that he had in getting his ideas understood and accepted by the geological community at the time. We look at him now as a hero, but at the time people weren't convinced. It didn't help that he came from a fairly modest background as well. He had to work hard to try and make his living. William Smith's biggest contribution to geology is in coming up with the first real geological map. This is an image of it. This map was produced in 1815, and when it did come out, Smith, who'd put this map together pretty much all on his own, travelling around the country on horseback, making observations, piecing together the clues that he saw, was able to produce this frankly remarkable document. It's actually a huge map that showed the geology of England and Wales as he observed it. No one else before him had produced a map of the geology. Now, Smith was trying hard to produce a useful document, not just something that was scientifically interesting or something that was beautiful, although it is both of those things. He was trying to produce something that would be useful to people who were employing their knowledge of geology, to mine owners, to estate owners looking for water, for example, thinking about their drainage, thinking about the rocks that could be quarried to build things, particularly in looking for coal. Smith produced this in the early stages of the Industrial Revolution. Let's have a look at some of the things that Smith observed and had to think about to be able to put together this map. As Smith was travelling around the country, he was able to see up close what the rocks around him were. At the time, transport would have been very difficult. Transporting heavy, bulky rock materials would have been extremely difficult and expensive. So people used the rocks that were around them to build the houses, to make the roads that he was travelling on. So he would have seen around him the really local rocks. And he started to make observations of these features that he found within the rocks. He saw these in the soil, in the road surfaces, and he started making quite a substantial collection. How do you think you would explain finding these things? What do you think they are? Can you describe them? How did they end up in the soil that was being ploughed in the fields around him as he was travelling, as he was working in different parts of the country? Have a go at answering those questions, parts A, B and C, on page 14. Now, Smith was a mining engineer. The search for coal at the time was really, really important. Finding local sources of good quality coal could have a massive impact on the prosperity of a region. This is a sketch of rocks that are found in a colliery in Somerset. Smith would have been working on similar types of diagrams. Now, finding these rocks in these coal mines got Smith thinking. He could see, for example, at the surface that he had rocks in layers at the angle shown by that green line. But as he descended the shafts of the coal mines, he could see the coal seams at a different angle. Can you describe those angles? He saw something else as well. Remember, he was looking for coal. So he's trying to follow coal seams through the layers of rocks underground. But it'd be really important for him as a mining engineer to be able to predict where those coal seams are going to be. Now, having found that zone of broken rocks, you might have expected the coal seam to carry on the other side of them. But in another mine shaft, he found that same coal seam at a different place. Why do you think that is? What's happened here? What conclusions could we draw about the geology of this place? What would Smith have been able to work out had happened to the rocks in this area? As well as just following the coal seams, Smith was also looking at sequences of rocks, trying to understand if there was a pattern. Because if you can understand the pattern, it'd be possible to predict where the coal was. What conclusions could you draw about the sequence of rocks here? If you were looking for the coal, where do you think you'd be able to find it? Have a go at question 7, parts D, E, F and G. See what you can come up with. If we think about the influence that William Smith has on our understanding of geology today, it's perhaps worth going back to this map. Remember, this map is over 200 years old. It was a map made by someone who'd never seen the ground from higher than on horseback. It's a result of largely his own observations. What he could see as he travelled round. Possibly about 10,000 miles a year on the back of a horse. He must have been a fairly tough guy to be able to do that. If we compare the observations that Smith was able to make on his own from pretty much ground level with what we'd see after 200 years of geological research, after the development of aerial photography, of satellite imagery, of all the boreholes that have been drilled through the rocks to work out the sequences, and we look at a modern map of Britain and its geology, we can see that it's remarkably similar. Smith, although he was missing some details in places, for example, like North Wales, particularly in places where there wasn't coal, there wasn't that drive to really understand the geology, we can see it's really very similar. So our understanding of British geology really comes from what Smith found. He found there was a regular sequence of rocks, a sequence of rocks that could be predicted by looking at the fossils that are found inside the rocks, by looking at the type of rocks that were formed. He could work out the sequence of rocks from the oldest to the youngest. Not only that, but the way that Smith drew his geological maps, the ideas he came up with, are the ones we still use today. This is part of the 1815 map that Smith published. This is actually Lincolnshire, up near the Humber Estuary. If we compare that to the 2015 map, it's a little bit more detailed, but the main structure is there. Smith understood British geology, and he was the first person to really put all that together and to show it in a geology map in the same way that we do today. Have a go at the digging deeper activity. So William Smith was a remarkable geologist. He pioneered the use of geological maps. He made geologists look at the landscape in a different way, to start to think about what was going on underground. These techniques that he pioneered are techniques we still use today. At the time, William Smith was dismissed by the geological establishment, by the Geological Society. Now, one of its most prestigious awards for applied geology, for engineering the rocks, is actually named after him. Make sure we finish all the activities in that booklet, including what's in a word, and I'll see you when we get back in class.